today into an advanced presentation of the ThymioAI software. And so let us start. I have presented a small presentation. So I will present today this solution, ThymioAI, to manipulate, visualize, and code artificial intelligence with educational robots. So this is a collaboration between the Learning Robots company and Moxia. And also to present myself, I am also a research engineer and a researcher at French CNRS, where I do both neurobiology and artificial intelligence. And I developed this software because I had a feeling that there was a need to understand AI and understand it in a concrete way. But this is I will develop very soon. So here is the outline of my presentation. I will start with the basics, starting by the main concepts, then going in the graphic interface, giving a live demo, showing the existing resources. Then I will go into advanced features because ThymioAI can be used from school to university. So I will show details of neural networks and other algorithms. And then I want also to give a word about features that are under development. So let us start with the main concepts. Please do not hesitate to interrupt me. I think that the video recording will be all the more interesting if there are some interaction between you and me, because you will ask people that you will probably ask questions that other people would like to ask, etc. So if we ask what do we want to teach about AI, so let's say we all agree that it is very important to teach AI, because AI we can see especially in this year 2023 with ChatGPT that it is really mind-blowing, and we will use it in all our jobs and all our aspects of our life. So we all agree that it is very important not only to know how to use it, but to understand what is behind, because it's the only way that will help us to master AI. But once we have said that, what should we really teach about AI? How deep can we go into AI? So we present AI as a black box, and we will open it in 3 steps. The first step for opening the black box is to use AI, to manipulate AI, and have a good understanding, especially of the concept of machine learning. Machine learning is we do not write anymore the code of that is behind this AI, but we provide data, and the AI adapts to this data and generalizes from this data. So really understand the concept of learning from data by manipulation. The second is go into the algorithms. And this is a very specific point that we make. I mean, many solutions to teach AI stay at the manipulation stage. We think that it is important to expose the algorithm so that people do not think that this is magic, and also that they do not think that it is too complicated for them. We want kids to feel self-confident, and we will show that a lot of concepts, for example, connecting neurons, are easy to grasp if we present them into simple configurations. The third step now is more advanced and will be only for the students who want to master by themselves, really. So it will be to code my own AI in a programming language, and our software is connected to Python. So you can code AI in Python. Now, how do we do it? So the solution of the AlphaAI software has 3 pillars. One is to use learning robots, because it will be very concrete for kids, but also for adults. the robot will learn in front of our eyes, and will make AI functioning very tangible. The second is a graphic interface, where we will use visualization to see details of the AI algorithm, such as here a neural network, artificial neural network. And the third one is a pedagogy, where we have thought in advance what are the key concepts to give, in which order, and we have resources like pedagogical worksheets, video like the one that we are making now, etc. These are for the concepts. And now we will start the program and give a small tour of the graphic interface. So how do we start the program? So to make the presentation very complete, I show that you can download it from our website. So you go to Learning Robots. You can just search Learning Robots. And then go in, let's make it in English, go to the resources, and then here you download the software. So there is today an installer for Windows, and we are working for installers for Mac and Linux. For the moment, the installation on Linux and Mac is a little bit more manual. So once you have downloaded the software, by the way, it asks for an activation key, so you enter your activation key, etc., etc. And then you start it, and it looks like this. So here, this is the version of the software for the Thymio robot. It might be when you start it for the very first time, it gives you the choice between different robots that you can control, so you will choose Thymio. Now, as is written here, it shows for your robot to appear in the list, Thymio Suite must be launched. So you also need to download and install Thymio Suite. So the same, I mean, you can find it from the internet, download the Thymio Suite, and you start it. Now you need, yeah, so now it started, it's good. And you need, so I will move the camera to turn on your Thymio. So I turn it on. And you need to connect the USB dongle. At that moment, the Thymio Suite will detect Thymio. So, yeah. So here is the Thymio which is connected. So you will ask me, what is this Thymio? This Thymio is a simulator. I forgot to turn it off before, but here you see I have a simulator. Let's close it. If I close it, it will disappear from the list here. If you want to use the AlphaAI software with the simulator, you do from here. Here it's in French. Lancer, start a simulator, and so you choose your simulator, and the simulator launch, and it will appear in the list. So to clear the case of the simulator, let me just show you. So before connecting to the true robot, I will connect to the simulator here. Now I am controlling the simulator. So you see, I can move it. I mean, as you can do from a real robot. So this is really useful if you want to test your activities, or if you do not have enough Thymio robots. With one license for one robot, you can in fact install the software with the simulator on 30 computers. So now I want to stop the simulator. I want to connect to the real robot. So here is the interface. And I want to give a general tour of the interface. So as I say, AI visualization is at the core of our software. So this is why there is a large room here for AI visualization. And here you see the activity of a small neural network. There are the gray zones are more like controls. So I have summarized this also in my presentation. So you have two zones, the control zone and the visualization zone. Now in the control zone, you have we call it the main panel or the main dashboard in the bottom, and you have a parameter configuration on the left. So this parameter configuration, the first four, each of them correspond to a very specific configuration for the AI. So for example, in the sensor, we choose which sensor we want to use. So for the moment, we are using the IR infrared proximity sensors and the infrared line tracking sensors. So for my first demo, I will not use the line tracking, so I turn it off, and we will use the 7 proximity sensors on the camera. I hope that on the video you can see both my screen and my camera. There are 5 sensors on the front and 2 in the back. So this is for the sensors, and I would like to show you also in my presentation that each configuration tab will correspond to a very specific place in the screen. So in the screen, for example, the sensors, you see here the input to the neural network. So this is the sensor. Then you see the AI, so the internal functioning of the neural network, and this is configured by the AI tab. So here the AI tab looks very complex with a lot of options. This is because we are in expert mode. So there is a very important option. So here you have a few menus. So there is one important option, which is parameter display mode. Here you can choose between standard, advanced, or expert. So let us start with standard. Then you can see less options. Let's continue. On the right, you have the actions. So in the actions, you can choose which actions you want Thymio to do. So for the moment, 3 actions are selected: go forward, go backward, or do nothing. So we will add actions. We will add a forward turn. We will add a backward turn. We can also change the speed of the actions. So do you see Thymio?
We do.
You do? Okay, so you see here I press go straight. So it goes at speed 150. I can increase it to 500. See, going much faster. So you can choose your speed. So these are the actions. So in the new version, which is under development, now you can create custom actions. So here you have a predefined set of 17 actions, but in future version, you will be able to create your own actions. Then I talked about AI, and then there is the reward tab. So this reward tab is used only for a family of algorithms, which is called reinforcement learning. I will explain later. So if I put reinforcement learning here, have a small message. You see, we have 2 new display here, reward and level, and they correspond to this reward menu. So as you can see, reward corresponds to here, reward. The last tab, visualization, has general options for different graphic elements. So for example, under the network sub container, you can choose input-output values to show more details about the neural network. So now these square, I will explain about them, become bigger, and you can see values inside. You can also keep space between neurons. This will separate them. So this will be useful when I will start explaining this neural network. So I guess I made the full tour. These buttons I will explain soon, and the disconnect button, I mean, is to go back to the connection screen. Okay. So let's advance in the presentation. Now I will give you a first live demo. So I will introduce the concept of supervised learning. So supervised learning is, let's say, the key of machine learning in general, and it is also the key of the activities in the AlphaAI software. So the concept is quite simple. In fact, we will create a database with examples of how should AI drive, and then we will
sorry to interrupt you.
Yes?
I think we are still in the reinforcement learning. We are not at the supervised.
Oh, yeah, sure. I will do all the configuration now for supervised learning, so I can start.
Thank you, Thomas. Thank you.
Here, learning type, supervised learning. And you see the reward is going back. So we will train, and then once it is trained, the network will learn, and we will be able to use. It is as simple as this. So let us do all the steps of the preparation. So in terms of sensors, we are using, I see that if you want to change the speed, you need to be at least in, oh, no, sorry. Instead, we will use the 5 proximity sensor. So you see, if I put my hand on the left, I activate the leftmost sensor, and it puts a value of 1 here. If I put the hand a bit further, the value fades away and becomes 0 when my hand is far. So then I go to the second sensor. You see, it's here. Then the third, which is the central sensor. Then the 2 sensors on the right. And the last 2 neurons that you see here are the back sensors. So left and right. Okay? So you can see that these squares reflect the state of the sensors, and each of them is activated with a value which is between 0 and 1. So one of the first thing, I mean, okay, I will first more talk about children because AlphaAI, you can use it from elementary school. And when my presentation will advance, I will talk more about students because I will be more in the context of usage at university. But let's, for the moment, talk about children because I am in the simple part. Okay? So you see that here, this first layer of artificial neurons, so all these black squares are called artificial neurons. All of them represent a value, and it is the very first thing to explain to children, or the first in-depth course will be to explain that any computer, if it wants to control a robotic device, needs to transform information about our environment into numbers, because you can do calculation on these numbers. So it is a very important thing to stop on these and explain these numbers here from the infrared sensors. Now we will configure the output. So the output, in fact, I already did it before. So we have output duration of 0.25 milliseconds. So there will be 4 actions per second. Here you can configure to do a pause between the actions, but we will not do a pause. We set the speed and we already selected the actions that we want to use. Now let us go into the AI. So for the AI, so we have selected supervised learning. We have chosen the neural network algorithm. So the neural network is something looking like this, where you have connections between the inputs and some other neurons, which called internal neurons, and then from these internal neurons to the output neurons. So here we define these hidden neurons, so we can put more hidden neurons in this layer, and we can even put several layers like this. So now you have a communication like this, but you can also put no layer. In this case, the input connects directly to the output. And in reality, the activity that I will show now is so simple that it works even with no hidden layer. So I will do it in this configuration. The learning rate is a value that you do not need to change. In fact, it should not be in the standard parameters, but more in the advanced parameters. So let us start the training. So I make sure that you see that learning is on, and I will create a data set. So let's say that I want to train Thymio to follow my hand. Yes. So I will put my hand in front of Thymio and tell him go straight. So you see, I constructed a first example, and this appears here where you have experience buffer 1. So we have created an information, and you probably are seeing how the neural network is evolving. You see that this line is becoming thicker and thicker. Also, the 2 lines on the sides. And all the other lines become very thin, and some lines, I mean, most of the lines connecting to other neurons become more black. So I explained this. It means that a strong connections was created between the central sensor and this sensor, so that when I activate this sensor, then this propagates to this neuron. And this neuron gets activated with a high value, 600. And you can see the other neurons, they receive even some blue color. Blue color means negative information or inhibition, and they are all going into negative value. So if so this means that now the model has learned to go forward, but we need to continue training it. Now we tell him when I put my hands on the right side, you should turn to the right. Okay? I will tell him when I put my hand on the left side, turn to the left. Now, if I put my hands in the back, turn backward, go backward. We will also try, when I put it, I mean, only on one side, go to this side. So this will be backward right, and here, backward left. And I should not forget a last thing to say, if you don't see anything, do not move. So the do not move action is this one. I have a phone call. Okay. 1, 2, 3, 4, 5, 6, 7. You see, we made 7 experience. So now, in fact, the AI is learning. You can see that now 0 sensor is activated, and the AI prefers to do one of those actions. But slowly, this action, you see, how this action is becoming stronger and stronger compared to the other. So this means that there is some learning going on. You see, initially it was preferring going straight, and now clearly it is preferring stopping. So because I want also to talk about more advanced feature, I will in fact activate the advanced mode, and we have a new button which is called graph, and you can see here a graph of the loss, which is the error when the neural network is trying to learn. So you can see that this loss is now decreasing, but initially it was 0, and then it first increased. So this was when I first selected the go forward action. So first there was some error in the predictions of the neural network, and then this error decreased because it changed the connection to facilitate go straight action. And then for each new action that I pressed, the error increased, but then the effect of learning was that the error is going down. So it will go down even further, but now I am confident that we can already use. Sorry, Axel, je suis en réunion. C'est impossible, je ne peux pas te le donner comme ça, désolé. Sorry. I was disturbed, you see. Now we want to use, okay? So we can, but we do not, it's not needed. We can stop the learning. So you see, if I stop learning, then there is no more learning here, and we can start using. So I use, and you can see the actions that the neural network chooses is do nothing. But if I put my hand in the front, it is following my hand. You see, so this is very fun to do with the children. So the reaction time is a little bit slow. This is because in actions we use a duration of 0.25. So I guess I can decrease the duration of action like this, and it will be a little bit more reactive. And now we can go also backward. You see, backward. We can also, if I have an impression that it did not completely finish learning when going backward. So I can also put self-drive off and check. So here I activate the two sensors. Oh no, it's okay. I see he wants to go backward. If I activate only one, it wants to go backward right. And if I activate only one, the other one, it goes backward left. So the learning was correct. What was maybe a bit difficult, it was the positioning of my hand. So this was our first learning. And I think that you have learned really the essential part. And now we will see how from this basic idea, we can construct many different activities. Do you have any questions at this stage?
Yeah, actually, I do. What are the hidden layers exactly? And how do they affect the learning?
Yes, of course. So you want to you want to know more advanced questions. So I keep these questions for later because we have activities especially to understand these internal layers. So I keep it for later. So let us go and check existing resources. So for the resources, it's quite simple. You go from here, from the menus, activities. No, let's start with video. Let's start with video. Maybe even I should have started from it from the beginning, because you have two very nice videos that we produces with Marie, which is our a PhD student. I mean, she was a teacher, and now she is my PhD student. She's doing experimentation on using AI education at elementary school. And so there are two videos. One is an introduction. You see, it's 5 minutes. So I will not play it, but I will just show first a few screenshots. So where she is doing approximately the same thing as I did. Like she did one demo with AlphaAI, explaining the learning and then the using. She, at the end of this video, there is also some words about reinforcement learning. This reinforcement learning I will explain later. Then there is a second video. Yes, so yeah. Oh, I see that I must improve the links, because the link here is the link to the French version, but there is also an English version. So if you want to, oh no, maybe no, we only have the, yeah, you can activate the English subtitles. Yeah, that's the thing. So you can activate the English subtitle, but I think that Ronnie made an English version and other language of these videos. So Ronnie, maybe you can also send me the links for the English version. So let's go to the second video. The second video is a 10-minute one, 11 minutes, and it will go more in the details, explaining all the steps also of the configuration. You see, all the configuration, I mean, everything that I did. So I really encourage that anybody who wants to learn about ThymioAI starts by watching these two videos. The other link was activities. So these activities were made by me and by Joël, who is middle school professor in France, and who is really an expert of using Thymio. So
Thomas,
yes?
just to give you some update, actually, Agraf, they already have them in Polish, Polish version.
Good.
Yeah, they already have them in hands. Yeah.
Very good. In fact, yes, I do not. Yeah, I do not have all the other languages. I should put all the new links in the software. So
sure. Okay, I'll give you the links. Actually, they're already published on our website. Okay. Yeah.
So you understood that there are students and professor version, and so here I am logged as AlphaAI. So I want to show you something. Let me sign out. In a basic usage of the software, you see only the students' documentation. If you want to see the professor's documentation, there is a trick in the software. You go here in parameters and you choose activate teacher mode. You put activate teacher mode. So the problem is that I do not have here my activation key for the software, but you should tell the clients that they should keep the activation key, because they might need it to activate the teacher mode. And if they activate it, then the link for activities will go not to Thymio student, but to Thymio professor. And then they will have more details for each activity. So for example, for this activity, you have professor and you have more info, such as giving the proper solution. You see, a table that gives the solution. So let me present very briefly the first activity, Thymio the Fearful. I can go very fast because it is just the same activity that I did before, with only a very small change, which is that instead of following the hand, we will teach Thymio to escape my hand. He fears my hand. So let me reset learning. You see with this button, reset learning. And I will teach him to stay, do nothing if there is no input. If I put my hand in the front, now he should go backward. And if I put my hand in the back, he should go forward. I mean, you can also train it to do specific turns, etc. But this is the idea. And so you see, if I put my hand in the front, it wants in the front. So this activates these sensors. You want to go forward. And if I put my hand in the back, it wants to go forward. So the opposite of before. And I can try it. So set drive. See? So let us go to the next activities. Number 2. The arena, I keep it for later because this is reinforcement learning. Number 3 is keep the track. So I go directly to the professional version. So there is a line. So Joel even made, I think, a model of the line. No. I don't know. I don't really know where it is. And so you put a line on the ground, and you select so these sensors, not anymore those, but these ear line. So these are the 2 sensors which are here in the back, and you can train Thymio to follow a line. I will not demo all these activities because I want to keep the time for the advanced version. And by the way, I can put the camera back to me. And, I turn all. Yeah, there is enough battery, so it's okay. Continue. The next one. Is do not stay here. So it's a very nice activity, a pure invention from Joel, that you will train Thymio to push object outside of a black circle. So you need Thymio to so this is more difficult for the student, but they will be able to do it completely with the supervised learning. They will activate both the front sensor and the line tracking sensor. The line tracking sensor will serve to detect when Thymio enters the black line, and we want it to U-turn when it is detecting the black line. And the front sensor, of course, will be used to detect objects. So here I jump to the solution for this activity, which is if I do not see anything, and I do not see the black line, I just go forward. If there is something in front of me, I go forward to push it. If I see an object on my left, I turn to the left to start pushing it. If it is on my right, I go to my right to start pushing it. And if I meet the black line, I do a U-turn. So this means that you have activated, you see, these specific actions: go forward, pivot 15 degrees, pivot 30 degrees, and pivot 150 degrees. And the last proposed activity, number 5, is the autonomous car. You will make a street with obstacles. You see, you put some obstacles. For example, you can use a paper. How you call it? something like this, and you put obstacles on the left and the right, and you activate the front infrared sensors of Thymio, and you can teach him with supervised learning to follow the street, and when it meets a black line, to U-turn and follow it in the reverse direction. So these are only examples. I would like to show you something really maybe more impressive that you can do with Thymio. It is to start doing object recognition with its front sensors. So you will say, how can it do object recognition? In fact, it can do, because when it is like here, looking at the table or at my smartphone, the reflection from the object is not the same. So what it will feel with its sensors here will be different. So let me do this training, because it is an interesting one to show that you can teach something to machine learning that would be very difficult to program with some code. It is.
Thomas, you may need just to adjust a bit the camera, please, so that we can see the table and the Thymio as well.
Oh, yeah. You didn't see it now? I didn't know it was not activated.
No, we see you, but just, no, we see you. But if you can just maybe rotate a bit.
It's
yeah.
not,
Yeah, perfect.
Yeah, okay. So you see, I will try to recognize the table, the pen, and the smartphone. So we will activate the proximity sensor, and we will use only the front sensors, not the back. Now we want to do something complex, so it would not work. These answers, it starts to answer the question from before. It would not work if there are no intermediary layer. So we will put 2 layers of, let's say, 15 neurons. Okay? And the actions, we will not do motion, but we will use colors. So the table will be red, the pen will be green, and the smartphone will be blue. Do you see Thymio everywhere? So you see, if I approach the table, depending on the distance, the values in the input will be different. So of course, if I am at this distance, it will be impossible to recognize the 3 objects. This is for sure, because all of them show 0, there is no difference. But if I go from a smaller distance, for example, you see here the table, and here the pen, you can see that in the pen, the reflection from the pen is a little bit stronger than here from the table. I mean, it is very subtle to see. So I'm not sure that if it will work with this pen, but you can see. Let's put another object that maybe will be better. Yeah, this will make the difference is stronger. Okay. So I start teaching, and here it's okay to put self-drive from the beginning. So I tell this should be red on this action. So now it's already choosing red all the time. Now I put on these objects, so it's still red because red is the only thing that it has learned so far. And I say here you should put green. So it goes green, and we can see the learning. So now it is struggling to make the difference between green and red. So you see error is decreasing, and when error will be low enough, it will, you see now it starts hesitating between red and green. See, it starts hesitating, and now error is becoming smaller and smaller, and it is doing green more often. But to train it really good, we need to give several examples, because only one example was only from one distance. So if I put more examples, it will be better. So now I continue training by giving more examples from different aids. So now definitely it chooses green, but let's see. The problem is that it also says green for the table. So now I need to give more example of the table, also from different aids. Sorry. Okay. Red. I continue the training. Ah, I must be careful, because if I go too high, all the sensors are 0, and definitely it cannot make a difference. I add some options. You see here there is a value which says how fast it learns. And I see that the learning is really slow. 5 or 6 is not a normal value. So you see now it works. Okay, so should we try the smartphone? I am afraid that this learning is really slow, and that it will not be successful. Let us try anyway, and let us see the graph. So you see, at the moment that I press blue, I create more discrepancy, and the error is increasing again, and then it will start decreasing again. Hey, it starts to work. Let us stop here. I want to give a comment between these slowing down. So I also noticed today that the robot is not over reactive. So it is an issue that we are currently working. In fact, we are working to make the robot more reactive, and to give a little bit of technical explanation about it. It's because each time we want the robot, for example, to do an action, we activate a variable which controls the speed of the wheel. But there are much faster ways to do it, which is to have a program which is constantly running on the Thymio and listening from instruction from the PC. So we are working on such program to make Thymio much more reactive in the future. So if you have a feeling that it's not very reactive, or that something are slow, like here, and this is related to these improvements that we are working on. So I hope that I gave you a large idea of activities that you can do with the supervised learning. And of course, the teachers will invent their own activities. It's really the idea that even the kids will start teaching something new because it's possible to train for many different behaviors. You could see even when we do the follow my hand or escape my hand, that with exactly the same configuration, we can train different behaviors, because what matters the most is not only the configuration, but the data that we give. If we provide a different data, we will get a different behavior. Now let us continue the presentation. So, yes, this was to summarize the resources. Yeah, good that we have it. So from the menu, you can get the Thymio activities. But now, if you want to have more advanced resources, I want to point to other resources that we have created for other robots. Because historically, the Learning Robots, our company, the Learning Robots company, chose a robot that we called AlphaAI, and we made a lot of activities for high school and universities with the AlphaAI robots. So in the future, we will also write resources for Thymio at these levels, but they do not exist currently. So I show them to you. So this page I already showed before. You see, it's the table of the activities. So these activities are mostly for high school. You have supervised learning activity, reinforcement learning activity, and Python programming activity. And in fact, what I will show you now in this presentation today is somehow adaptation of those activities for the Thymio robot. The second thing that you might be interested in is a 24 hours course that we gave in University Paris-Saclay, and that we will give 4 times this year. So here I put the link, and I will send the presentation to you. So you see, of course, it's only in French, so sorry that there is no English version. We start with an easy activity, and then we go in the depth of different algorithm. So you can see how we imagined a 24 hours course. Of course, the activities that we use in this course are, in fact, the same activities as here, but in the course, you can see how we decided to organize them. So now, to finish with the basic overviews, I want to make sure that we made a full tour of the interface. So let's go back to the interface and see if there is anything that I forgot. But you see, I put myself a note. Don't forget the simulator, and the simulator, I already talked about it. So to make it clear, in the top, we have the menu. Here we have the configuration. Here we have the main dashboard, and here we have the visualization. So in the menu, we have load parameters. Yeah, this is something I didn't say, that all this configuration, you can save them to a file. So here, for example, this is the configuration for recognized object. So I could save it, save parameters. Let me put it on the desktop. I call it save, object recognition with Thymio. And now I have a file on my desktop. I don't know, I see it on my desktop, but on the desktop I don't see it. Maybe my desktop is too messy. Here it is. Object recognition with Thymio. So you see it's a JSON file. In fact, it's even a file that you can read. You see, it's all the parameters. And of course, later on, if we have, let's say, close the Alpha program and we restart it, you see, this is the default view. I can reload my parameter. Okay, and here there are a few demo parameters. So obstacle avoidance is another activity which is really, I mean, it's somehow similar to the activity the street, where Thymio navigates and has to avoid obstacle. Obstacle avoidance, no, hand control is the one where I push with my hand, etc. Line tracking is the activity that is also in the resources of following with the line tracker. And we have also two activities with reinforcement learning. I will go to reinforcement learning later. So you can save your parameter, your configuration, and also load demo parameters, which are also already available when you start the program. Then you can set the language. So I hope that we will add Polish soon. So to add Polish, it's quite simple because we have an Excel file with all, let me show you here. This is our code, by the way. Where is local? We have, yeah, here. An Excel file, you see, where we have all what we need in the software, and it is translated for the moment in French, English, Italian, and Dutch. So it would be easy. Maybe if I ask your help, I mean, we will first do with Google Translate, and then we will ask your help to proofread, to add Polish. So we could have the full software in Polish. Parameter display mode, I already told you about the 3 modes. Teacher mode, other settings, you can change the fonts. Sometimes the fonts are not very visible, so you can increase them, you see, make them bigger, smaller. Then AI is to save the state of the network. So if I teach Thymio to follow my hand and I save the configuration, I do not save the result of the training. The result of the training is something separate. And for the same configuration, you can have different training. For example, one training for following my hand, another training for escaping my hand. So this is why it is a different menu where you can save the training and load the training. And in fact, the training consists of 2 parts, which is the data set that you created and how the model, the neural network learns. So when you will save, it will create 2 files, one for the data sets. Here it is called experience buffer, and one for the result of the training. And by the way, I want to show you something in expert mode. If I here I put expert, no, this is a new feature. It will be, yeah. So in a new version that we are working on, when you are in expert mode, the learning button dissociates between 2 buttons. One for acquiring data and the second one for training the model, because we want people to be aware that learning is 2 steps. Is I make a data set and the model learns, it gets trained from the data set. So community, so in help, I mentioned activities, videos. So about Alpha is useful to know what is the current version that you have. Changelog is useful to see what is new in the newest version. And a community is a Discord server where you can discuss between users. We have discussions, and we are very fast at answering people. We put FAQ. I mean, for the moment, it's all in French, but at the moment that people will start asking in English or other languages, we will also answer in English. So we are done with the basic overview, and we will go in the advanced feature. Maybe you have questions at this stage, or you want a small pause, just tell me.
Yeah, maybe we will make 10 minutes break.
Yes?
Yes, 10 minutes break. Is that fine with you?
10 minutes?
Yes, 10 minutes. Yeah, 10 minutes.
Okay, let me load the demo parameter. So now I take the hand control because I told you, yeah, it's the one that we made before. So I want to explain all the details here. So first of all, the neurons by default, they align like this as a line. So you can separate them to see better by doing this. Check. Okay. Then you can click here to see the input inside the neurons. Okay. So now we have all the values. I mean, not for all the neurons, but at least for the input and the output. Also, I want to make maybe I will make the neural network simpler so that we can see more things. So I will remove some actions. I will remove some sensors. And I will remove the layers in the middle. Okay, very simple network. Because now we can put all the network values like this. Network values. So now we see the exact calculations that the neural network is making. For example, this neuron, its activity is calculated as the following. 0 multiplied by 0.05 plus 0. Oh, let me increase the fonts so that you see better. Maybe. Ooh. Okay, you see well? I guess it's good. So, plus 0 times 0 plus 0.44 multiplied by 0.01 plus 0.23 multiplied by minus 0.25 plus 0.58 multiplied by 0.31 and minus 0.06. So you see this value here, it is called the bias of the neurons. It is the value when there is no input. So by the way, the inputs, you see the inputs, there is some input from the neurons, but we cannot, right now, we do not see these inputs go from the left to the right. So to see the inputs, you press connection activity. Now you see some animation of waves of inputs. For example, you see waves for the blue here, but you can remove the animation and it is more static and you see even better. So you can see that this neuron receives essentially a positive input from this neuron and a negative input from this neuron. So what is interesting is that if you look, this neuron is more activated than this one. But the connection here is only 0.01. So 0.44 multiplied by 0.01 is very small. So this is why you don't see any activity going from this neuron to that neuron. On the contrary, this neuron is less activated. It's 2 times less activated than this one. But the connection, it is a negative connection, by the way, is minus 0.25. So 25 is 25 more than 1. So this is why we see some blue negative activity spreading from this neuron to that neuron. And now, if all the neurons here are off, so I put the robot wait, Seems that I lost the connection. Let me save. Oh, I forgot to say something in the parameters. You can save the default parameters. So if I do save by default parameters, and I turn off the program, then this is the parameters that we will see when we will start the program again. So it's very useful if you want to quit and come back in the same state. You see? In the same state. So only the values have changed here. But now, you see, here, there is some inputs from the neuron, because let me flip the camera back here. I control. Yeah. So you see here, there is some inputs. So there is some activity spreading from the input to the output. If I remove my hand, all the neurons in the left are 0. So the activity of the output is only their baseline activity. So this one has a baseline of 0.04. So you see activity is 0.04. Here 0.05, here 0 minus 10. If you put some input, yeah, if you put some inputs, there is a complex calculation. For example, this here, there is input only from here. So the calculation is 0.04 plus 0.36 multiplied by minus 0.32 equal this. Okay, so now if you are with people who can understand all these equations, you can redo the same activities, but explain all the details. Let me add the do nothing action. So here I will teach again Thymio to follow my hand. So I say when there is nothing to see, do nothing. So I press this, and we see immediately that you see this baseline activity of this neuron becomes very strong, and the other baseline activity becomes negative. So now we understand why this neuron gets more activated than the others. Now I put my hand, and I press go straight. Immediately, you can see how this connection is increasing. You see this one? And the other connection, and also here you have a connection which is becoming more and more negative. So that when I put my hand, this neuron is boosting the go forward action, but it is also inhibiting the do nothing action. You see the action of this neuron is positive here and negative here for a reason that we fully understand now. Okay, so now, in fact, we already understand how a neural network works. We understand, so I have already shown the graph. So let me do it, but I want to repeat and repeat because repetition is something important. So, I'm just considering using the newest version. It's maybe risky. So let me reset learning. I redo a second time. I put the graph this time. I will click here. This will generate a first data point, which says when there is no input, do nothing. And okay, but I will stop learning very fast. So you see, initially, there was a strong error. You see, there was an error because the neural network did not predict that this action should be selected. So the error was strong. But there is some optimization process going on, which tries to change the connection until the error will become very small. So if I reactivate learning, we can see that the optimization occurs, and this value of the bias is increased and increased, and thanks to the optimization, the error goes back to 0. Now we repeat. I put my hand and I say go straight. So there is a new error which was even stronger than the other, and then the optimization changes the connection. It increases this connection and decreases this connection, and also changes the bias here and changes the bias of the other action. And after sometimes the error is again very close to 0, and we have finished the learning. So this is the main thing. So now, if we put an intermediary neural layer, like we will start with something small. We will put like 8 neurons. Let me make it more simple. I will use only the central sensor, only one sensor here, and maybe 8 was too much. We will put, I don't know, 4. We will repeat the learning with some internal neurons, and again, we want to understand all the details. So I will even remove the turning actions. Yeah, this is enough. If there are too many neurons, it's confusing to see all these numbers. It's too difficult to analyze. So now let us analyze everything that we are seeing here. Input is 0, so there is no activity spreading from here. Now we have 4 neurons in the middle, which have a baseline activity of -0.68, 0.14, -0.20, and -0.63. These neurons, they also have a rectifying activation function, which transforms the value. So the value initially is -0.68, but it's transformed to -0.03. Let us choose rectifying options, a function which is extremely easy to understand. It is the ReLU, rectifier linear units. So to see it, we must be at least in advanced mode. I choose ReLU. And I reinitialize the network. So this rectifier changes the activation. If it is positive, it keeps the value. For example, here the baseline is 0.69. It keeps this value. F of 0.69 is 0.69. If the activity is negative, then it replaces by 0. -0.95 is transformed into 0. So you understand that now we have 2 neurons with 0 activity and 2 neurons with some activity. And then these 2 neurons, they activate the 2 actions. But now we will start the learning. We will say, okay, when there is no input here, I want some activity in this neuron. So immediately look what happens. The baseline here increases, but also the connection from the 2 active neurons increase. You see that this connection increase, and also this connection decreases and becomes negative, because the optimization process finds all the changes that will decrease the error and make this activity much stronger than this activity when there is no input here. And you see, if we go to the graph has turned back to 0. Now I will put my hands, so I activate this neuron. We see that this neuron is strongly activated, is activating that neuron. And also this neuron is inhibiting the other ones, doing some inhibition on the other ones. And now I press go straight. So immediately you will see the error will increase because right now the neural networks prefer to choose stop. So I say go straight. Immediately we have a strong error. But the neural network is thinking, and now it is making, you see, an inhibitory connection here, a negative connection here, so that when I put my hand, this neuron is shutting down this neuron. And because here we have a stronger baseline activity, these neurons wins over that one. So you see, without my hand, this neuron wins. With my hand, this neuron wins. But the way this one neuron wins or the other is more complex than before. It's because there are different paths that were activated or deactivated, etc. But the basic calculations, you see them here. So this is the general presentation. What I have done in front of you could be an activity. And now I will present you more activities that we have thought about to do all these explanations. But I want to go out of the neural network for a moment. We will explain more about neural network later, but now I want to go to another algorithm, which is the k-nearest neighbor algorithm. So this algorithm is interesting because it is very intuitive. It is doing what we expect somehow. So I will use it inside the arena. We will train Thymio to go straight in the arena, but when it sees a wall, to turn in the opposite direction. Sorry. So let us do the settings. So I will use two sensors, the side sensors. So those on the left and on the right. You see, I activate one and the other. For the actions, we will use forward, turn, and maybe we will also use I want to check if it's facing a wall. Yeah, we will also use backward. Okay. And now we will change algorithm. Instead of neural network, we will use k-nearest neighbor. So it says the network cannot be displayed. Of course, there is no network. So here in the visualization tab, instead of visualizing the neural network, we want to visualize the state space. So state space is to see the data, but this is available only in 1D or 2D. It means it is available only if we have one sensor or two sensors. So here it's good we have two sensors, the two on the sides. So we have a graph, and you see inside this graph, the graph goes between 0 and 1, and it shows a point that shows what represents what the robot sees. So for example, if the robot sees a wall on its left, you see the value, the x coordinates has increased. You see, like if I go a little bit, you see, so now it doesn't see the wall. Here it starts seeing the wall, and then it sees it stronger and stronger and stronger. Okay. And here the same for the wall on the right. So it will modify the y coordinates, and of course, if it sees something from the two sensors, the point will start moving. You see, it will move all around. Okay. So now I want to teach the robot what to do in different situations. So I will tell him, when you don't see anything, you go straight. And you see now it has created a point here, which is memorized, which says when I am at 0, 0, then I choose the action yellow. Okay, and but here the point is what I see. So the big point is what I see now, and the other points are the points that I have saved in my experience buffer. So now I will tell him, I will teach, so the connection I will explain later. Now I will tell him, when I see a wall on my right side, I turn to the left. So you see, I have made a second point, which is circled with some red. Again, maybe here I still see the wall on my right side, so I turn to the left again. Now I will put a wall on the left side, and I say, turn to the right. Okay, and now I will put a wall very close, and I will say, go backward. So now, how does this algorithm work? It's watching, it's monitoring what the robot sees. So what the robot is seeing is this. So if what the robot sees is closer to a blue point, then you see the connection says, oh, I feel close to a blue, so it will choose, I want to do the blue action. So I want to go backward. So I can press single step to instead of doing self-drive and the robot will move and move and move, I do single step and it will move only once. Okay? Now, the robot is at 0, 0, so we don't see the connection because the point is superimposed on the other one. So the robot want to do 0, 0. So if I do single step, we go forward. Now, if it is like this, you see it's doing a connection to turn to the right. In fact, whatever is the position of the point inside this space, there will be a decision, and the decision is decided by the closest neighbor. So there is an option here in the visualization which says show background, and I press it, and you see it is coloring all the space, and it says, okay, when I am here, I will choose yellow. If I am here, I will choose red. So turn to the left. Here, blue, go backward. And here, green, turn to the right. So let us try with self-drive. You see, green, now yellow. Now green again. Oh, now green again. Now you see it entered the blue and it went backward. So now blue and it will go backward. So you see, it is very clear. It is very clear to understand this algorithm. I don't know what you think, but for me, it is very intuitive, and it is a formidable way to show that, after all, machine learning is not so difficult. Even you know what? When I talked with the investor to invest in our company, I first I first do the demo without showing the screen, and the people they were very impressed that it is so easy to train a Thymio robot just with a few examples, and he knows what to do. And then I show on the screen, and all of a sudden, all the explanation is very clear, and it looks like, in fact, it's stupid. The algorithm is extremely simple. So there is one thing regarding this algorithm is that, let's say that I made, in fact, much more data. Okay, so now I will train Thymio for a longer time. But I should also make mistakes from time to time. You see, now I start to train it, but not in a very systematic way. You see, now because I make more points, but I am not very systematic. Here, for example, I say this. And here backward. You see, I start training, but not in a very precise way. I start to make a landscapes which looks very strange. Okay, and if I put now Thymio, it will not be so systematic in its decision. Though it's okay, but sometimes it will. Here you see, here, for example, we have a problem. It is in front of the wall, but it wants to turn to the left, making a big mistake. So how can we fix this? How can we fix this? We should say, okay, I made some training data, but inside this training data, there are some which are incorrect. I want to filter out the incorrect. So when I take a decision, I should not trust only the very points which is closest to me, but I would like to trust a small assembly of points around me, which will be informative to me. And this you can do by changing here the number k. So if I say I want to trust 3 points, or even 5 points, or more, you start to have a map which is more informative. So if we want it to work well, I must give more example of the go backward action. Okay, and now you see if I increase, you see now, because I increase the number of neighbors, I have again 4 homogeneous zones. If I look only at one neighbor, I have something horrible. If you look at 9 numbers, or 8, 9 was even better, I have an homogeneous zone, and which will result in a nicer behavior of Thymio. So I hope that you enjoyed understanding this algorithm. I will save these parameters, by the way, because I think they are nice to keep. K and N with Thymio. And now I would like to go to something very different, which is Python programming. Why now? Because KNN algorithm is a simple algorithm, and it is possible to have students, even from high school, to code it by themselves. So maybe we will not code the K option, so we will do it only with the K equal 1. So we assume that the training is not dirty like this, but I want to save these points, by the way, because I will reuse them later. So here I say load experience buffer, save experience buffer, and I call it dirty data points, dirty data for KNN. So we reach the next part, Python programming. I choose here algorithm, student code. And I have this pop-up window which says, do you want to create a new student code or load an existing file? And I say create new. So it asks me where to save it. So I will save it on the desktop, student code for Thymio. So you should not put space in the name because Python cannot cannot load a file name which we find where there are spaces in the name. So I put underscores instead. And now it opens a window showing me the file, and I can open it with my preferred code editor. And what is in this file? There are three template functions. Init, learn, and take decision. Maybe I can increase the font size so that you can see it well. So why these three functions? Because an AI, I already showed, you see these two buttons, that there is learning and using self-driving. So in learning, I also explained that there is the acquisition of the data and the training of the model. So the acquisition of the data will still be performed in the main computer, but the training of the model will be performed by this function, learn. And the use will be performed by this function, take decision. And before we do any learning or decision taking, sometimes we also need to do some initialization. For example, when we have a neural network, first of all, we need to create this neural network. But in the case of the KNN, we don't need to do anything in learn. And this is even more strange. We don't need to do anything. We don't need to do any init. And we don't need to do any learn other than acquire the data points. Because when we take a decision, we refer directly to the data points. We do not refer to a specific model, such as a neural network. So all we will have to do is to write the code of the decision taking. So now I want to go to the link that I showed you before. Here you see on the AlphaAI documentation page. So of course it's an activity which for the moment is written for the AlphaAI robot, but it will be just exactly the same for the Thymio robot. So practical work, KNN algorithm. I download the documents. And let's go in the programming part. Here. It starts by asking questions to understand about these functions. So we will work essentially with the take decision function. So it says add the print instruction, print sensors to understand what is the input. So here I add print sensors, I save. And now in this window, we see the results. So you see this black window is the window, the console, which opened when I started the AlphaAI software. And by the way, now we will work in a sort of multi-window mode. So let me organize my window. So I will put the software only in a corner. I will put this display here, and I will put my code. Okay, and you also see, so now you see, if I put the robot in the middle of the arena, the print becomes 0, 0. If I put it a wheel on the left, it shows like this, and here it shows like that. Okay, so it's very clear. It represents a value which says which sensor is activated. Now, let's say, what is this return? Return is what the function return. So if I press self-drive, we can see that the robot always turns to the left, because return is 0. If I put return equal 1, the robot goes straight. If I put 2, it turns to the right. And if I put 3, it goes backwards. So the return is simply the number of the action, 0, 1, 2, 3. Very simple. So in fact, we can already write a small deterministic program that will say, for example, if the two values are 0, if sensors 0 equals 0 and sensors 1 equals 0, so go forward is return 1, else and otherwise, if sensors 0 is more than sensors 1, which means there is a wall, I see more a wall on my left than on my right, so I want to turn to the right, return 2, else return 0, turn to the left. Let us try this small code. Yes. Okay. So whenever the robot sees a wall, okay, so it's too late. My code is not perfect because it's not including the backward, but it's really good enough. So you see how we can write code in Python. And what is very nice is that we do not have to care about the communication between the Thymio and the computer. We only care about the AI, the decision taking. But now we want to do a decision taking which will be based on data that we have learned from. So now, of course, to do it fully would take too much time. So I will open a correction and explain to you. I need to find this correction. Oh, you know what? The correction, you can have it from the website. Professor, answers. Okay, so let me copy the solutions and also comment. So learning is completely done. It's only that I will copy the data. So this code basically does nothing. It's just that when it receives a data set, which consists of X is the position of the point. So you remember this point, its position. of, I mean, the position of all the points which are in the database, and y is all the associated decision. Then we store them in some global variable that will be possible to use also in the take decision function. Now for the take decision function, we will need first code the distance between 2 points. So let me take it. So this is the code for distance. So we need to do an import mat to have access to mathematical libraries in Python. And then you see it's the square root of the difference between the points elevated to the square. And we can test it by making like this. I will do even, you see, you know that a triangle which has a side of 3 and a side of 4, we do like this. The hypotenuse should be distance 5. Okay, if we have a point at 3, 0 and a point at 0, 4, the distance between the two should be 5. So I save, and now the result of the print will go again in the console. You see, it shows distance 5. So this is correct. I have a correct distance function between 2 points. Now, x is not a single point. It's all the points from my data set. So I will have a list of points, and I must compare my points with all the points in this list. So I should also make a function to compute the distance between a point and a list of points. So it's here, compute all distance. Oh, you know what? I also want to save things. So I will go a little bit backward to save the code that I wrote before, you know, when I did this deterministic coding. So let me do Control Z. Ah, yeah, this one. Okay. So this one I will save as. No, I'm afraid. So this will be a simple code. Okay. And now I go back to save KNN. Oh, connection with robot was lost. I will also turn off Thymio to save the battery. No, it's okay. It still has a lot of battery. Ronnie, you will have a lot of moments to cut. I'm sorry. All these hesitations. Took decision. Yeah. Okay, and now I go back to what I have. Okay. Now, so all distance, you see, if I have A and a list of points, I return a list of distances. So now I test it, compute all distances. So you see, if I have A equal 3, 0, and I have 3 points, 0, 0, 0, 4, and 1, 0, the distance should be 3, 5, and 2. Okay, so let's save and see what it will, if it will be saying correct. Yeah, distance to data 3, 5, 2. Very correct. Okay, so now we are almost done, because what we need is to say, okay, I have 3 points, which is the closer? The closer, in this case, is the last one. So we need a function to say what is the index of the minimum in a list. So here I have my function. I copy it, and I print the result. Minimum of the list, so let's try it. Index of minimum 2. This is correct, because you remember the indices, they start at 0. So this is 0.0, this is 0.1, this is 0.2, and this is the closest point. Correct. So now we need to pack everything together. We will do our take decision function. So in take decision, I do. So I have my sensors, my new sensors, and I compute all the distances with trained sensors. Then I look for the index of the minimum, and I choose the train decision at this position. We can try it. Yeah, no, we don't need a. Yeah, yeah, take decision. Yeah, it's okay. It's okay. There is, yeah, you see, I have an error. Here it says non-type object is not scriptable, because I forgot one case, is when we did not learn anything. So we say, we must here say, case where there is no data yet. If train sensors is none, return. Let's return just the first action. Okay. Okay. So here, so this is we already improved these aspects. So I'm using the current official version of the software, but in a new version that we will be released soon, you don't have all these error messages. Here is because there was an error, and the program entered in a strange state. So I need to maybe reselect the algorithm to not have these. Wow. Change flag. Okay. See, now it's working, but in the new version of the software, you don't need to do this. Okay, no error, but no data yet. So let me train the Thymio. So seems that we lost the connection again. Okay. So I will load my demo parameters. No, not this one, but the one that I saved. Oh, I had saved KNN. I did not save the student code. So let us do it. Student code. Load existing. Student code 1. Ah. Okay. It's working now. And sorry for these bugs. Of course, we are constantly improving our software, but in these advanced features, sometimes
Thomas?
yes.
Maybe for the sake of the presentation, maybe we can carry on. Well, we understand, and maybe later on you can also send us like some documentation and maybe some videos on how we can carry on the programming with Python. But we understand that it's possible to do. We understand that you know, we can extend the learning through Python. In case we fail to do it now, maybe just what if we can carry on, you know, with the remaining topics of the presentation.
Yeah. Sure. Okay. But let me load parameters. I just want to make sure that it returns to yeah. Yeah, so maybe this was not fully tested with Thymio. No, but it was. There is no reason.
Agraf team,
Yeah.
do you have do you have maybe some questions actually regarding Thymio and I mean Alpha E and Python? Are there maybe like some questions maybe relevant to your experience of the market and maybe the target audience you are focusing on?
I mean, at least in my opinion, it's hard to say. I would like to know as much as possible, but at the same time, this is kind of complicated, to be honest. I'm not that much into coding, so
this is the same. I mean, just to make you feeling comfortable, Matthias, I've been already lost for quite some time, because what we present, you know, of Thymio usually doesn't go to this extent. At the same time, it is the beauty of Alpha E and the beauty of the software. So it is good to know that, you know, schools, if they want to, high schools, universities, if they want to, they can really go and extend far beyond the simple features of what we present with ThymioAI.
I actually have a question regarding, like, is there like some besides those activities that we saw, is there like a broader documentation with more detail so that we can actually gather the information from that, also, like, for example, send it to schools? Maybe it's more like to Thomas rather than you, Ronnie.
Sorry,
Thomas?
I did not understand the question.
Yeah, so you are currently showing us a lot of like Python, and I was wondering if there is like some documentation regarding how to actually use it with Thymio, because this is like you're showing us a lot of good examples, but I feel like we're kind of just like going into certain stuff instead of actually having information that will then later relate to teachers and to students, especially on a higher level. So besides those activities that you showed us, is there like a documentation on this or no?
Yes, it's funny that I forgot to say when I presented in the beginning, but I presented the activities, but I forgot this one. There exists a general full presentation of the solution. Let me Yeah. This part, maybe if you can really insert it before when I was presenting the resources, because I forgot to present that.
No worries, no worries. I was just like wondering. It's great that it's out there. I'll take a look into it later.
So there is a PowerPoint presentation which presents the concepts and the activities, and I will also share this presentation, even though it is not as developed as the other one. And there is installation and general documentation documents with all the presentation of the software. So this is like license activations and describes all the menus and all the details. I must say that this document is at least 1 year old. So some features have changed, and of course, it does not mention yet the Thymio robot. So, but you have the link for the document. It's on the web page, and the document will continue to evolve and show more up-to-date details.
Thanks, Thomas. That's extremely helpful.
You're welcome. So now I wanted to say, regarding what I thought was a bug was not. Look, when I put my hand in front of the robot, nothing happens because I forgot that the sensors that I was using were those on the side. So if I put my hand on the sides, you see that something happened. So sorry, you saw me struggling for a moment, but it's just because that I forgot which sensor was activated. Okay, so now in fact everything is working, and I can use our Python code where we coded our first AI. So we can retrain. So we make the data points in the software. So here we teach him to go straight. I will only make 4 points. Here I teach him to turn to the left. Here I teach him to turn to the right. And when both sensors are activated, I teach him to go backward. And now, let's go, and you will see how the robot will, thanks to our own code, choose the action which is most appropriate, depending on from which point it is the closest. You see, getting close to the red, do the red action. Getting close to the green, do the green action. And getting close to the blue, do the blue action. So I think that this is very compelling for students, that they are capable of doing their own AI code. Now let's go on. 2D graph. So 2D graph, we already saw it. It is this, the 2D graph. But the 2D graph can also be used with a neural network. So let us see how a neural network can estimate from these data points. So I will go back to neural network, and I will put a double visualization, neural network and state space. So now we have the two of them. And I will reload, remember when we have created the data points, dirty data for KNN, I reload them, and I start the learning of the neural network. By the way, I will start without hidden neurons, and then I will repeat with hidden neurons. So learn. So you see, it will try to make zones between. You remember that this point we should go straight when in we should go straight when we are at 0, 0. So we should choose yellow at 0, 0. We should choose red for the top point, and we choose green for the bottom points and blue for the points in the middle. And you see that the effect of learning is indeed to create these zones. So the program is struggling to make the zone perfect, but this is because of the dirty points that were created before. You remember that there were some dirty points. So it's making approximately the zone that we want. And here we could already use it. And you see when the program goes in the green area, now we go maybe in the blue area. So you see that as before, the small points indicate the data points from which the neural network learns. The big point represents what the robot sees now, but now the background colors corresponds to the neural network decisions and no longer to a nearest neighbor decision. Now let us repeat the same, and you can notice that the shape of these areas are straight, separated by straight lines. If we put some hidden neural layers, we put, let's be crazy, let's put 2 layers of 50 neurons. And reload the points and start learning. You see that because of these intermediary neurons, the shapes are no longer straight lines. So thanks to the intermediary neural layers, the neural network can adapt to more details and do more fancy separation. And maybe it will become even capable, I don't know, to isolate some dirty points. Okay, so you see the state space in 2 dimensions is very nice to even compare 2 different algorithms. And of course, this state space is a very classic concept in machine learning, and you find it in any course on machine learning. Now we will go even deeper in the neural networks with the 1D graph. So in this case, we will be capable of seeing even more details because we will activate only one sensor. So let us activate only one sensor. Instead of the 2 side sensors, we will use only the central sensor. Let me remove all these neurons in the middle because they are making us crazy. I would like also, yes, what I will do is to choose the action. Okay. Okay. So because this is new with it is new. So let us choose this action. So the color action do not work in this setup. I need to figure out why. So what I will do is to put Thymio on a small support so that I don't want it to, I will put it upside down. Okay? No, it's not nice. Maybe like this, so that even when turning the wheels, it will not move. Okay? So this is also a long activity. So I think that the presentation is already quite long, and I will not go into all the details, but I will illustrate what is possible of doing. Okay, or I will go very fast, very fast. So now we say that Thymio is the story is that Thymio is controlling a baby Thymio. Okay, there is a baby Thymio, and it wants to detect when baby Thymio will go out. Okay, and maybe make an alarm or move, make something when the baby Thymio goes out. Okay, so basically we want to choose the action do nothing when baby Thymio is at the good distance, and raise the alarm when it is changing. Okay, so so in this activity, it's also the students can try to find by themselves what are the good connections to set up. So if we so now we will do manual edition, and everything is at 0. So if I press set drive, I mean everything is at 0. But I can here say that by default the so when baby Thymio will go out, you see that the distance here, this will decrease. Okay, so we could say that we want to that when distance is high, this neuron will be selected. When distance is small, this neuron will be selected. So here I will put a baseline activity, let's say of 1. There is an option that we need to set up is advanced manual edits. Okay. So here I put a baseline activity, and here I put an activation, for example, a connection of 2. 2 will not be enough, of 3. But now look at the graph. We see for different values of the sensor between 0 and 1, if sensor is at 0, so baby Thymio is out. It's on off and on. Maybe Thymio is tired. I bring it closer to the computer. So if we lose connection like this, we can go into Thymio Suite and see if it appears in the panel here. I will unplug and replug the dongle. Yes, connection is back. So as I said again, we are working on all these connection things. Now it's the program which froze, so let me save. Very detailed. Baby graph 1D, baby Thymio. Okay, you see, it reacts. So let me put back what I have done. So here I put a baseline activity of 1, and here I put a connection of 3. So you can see when baby Thymio is out, so input is 0. So here the yellow curve is at 1 because it has a baseline activity of always 1, and you see it is this curve. Whatever is the value of x, the output is 1. But when x increases, the value of the black curve, which corresponds to the black action, is increasing. So you can see if I approach baby Thymio, you see the value here increases. So here I have programmed by myself a neural network which is capable of making an alarm when baby Thymio goes away. So let me press self-drive. Here, baby Thymio is here, no problem. Now baby Thymio goes out. Oh, an alarm. You see, the big Thymio is running to chase it. Okay. Okay, and here we have gone one step more inside the neural networks. Even we let students learn by themselves, try to put connections by themselves. Of course, we could have used automatic learning, so I do the same with automatic learning. We say, okay, now baby Thymio is at good distance. I do nothing, and now baby Thymio goes too far. We say do the action, and now automatically you can see the connections change, and here the curve also change, and now the curve starts crossing and making two zones. One yellow zone where one yellow zone where the alarm is raised, and a black zone where there is no alarm. And in this activity, we go, you see, very deep, and we want even also to understand what happens when there are hidden neuron layers. But in this case, what we do is that we say, okay, we would like also to make an alarm when baby Thymio goes too far, too close to me, because I don't like that he's, hugging me too strong. And in this case, you can see that because we have a simple neural networks, the zones are separated by two lines, which with equation y equal a times x plus b. And you know from primary school that two lines can cross only one time. So we cannot have the two lines close two times in order to have a central gray zone, and on the left and on the right two yellow alarm zone. So in this case, we need to put a hidden layer. So I will put, let's say, 5 neurons. And you see that thanks to these hidden layers, we do not see any more straight lines, but we have broken lines. So in this case, it will be possible to train, and I will do the training. So here at intermediary distance, I say do nothing. At too close distance, I say alarm. And when at too long distance, I also do alarm. And you will see now the process of learning is going on. I can do a small thing to speed it up. So you see that the two curves, the yellow and the black, they come closer and closer until they will cross, and they will even cross 2 times, and the trick will be here, and it will be working. You see, they are getting closer and closer. These numbers, they are smaller and smaller. Yes. Okay, so now we have our 3 zones. Continuing to evolve a little bit. Let's wait that it will be stabilizing. Or we should also watch the graph. You see how the graph of the error has been decreasing and decreasing. And now it's coming very close to 0. So let's try. Here, Mama Thymio is not happy. Kid is too small. Here, she's happy. And here, she's not happy. It is too close. But I went fast this time, but it's possible to comment all the details of these equations here in the neural network. We are close to the end, but we have a big thing to finish, which is reinforcement learning. So are you ready for reinforcement learning? Or do you have questions from what was before? No?
I think we can proceed.
Yeah, okay. Oh, you see, it stopped when it was at the correct distance. Reinforcement learning. So the concept of reinforcement learning is different from what we have seen here before, because so far we always trained with examples. We were first showing what to do in different situations, and then the AI was learning from it and repeating. In reinforcement learning, it will learn from a reinforcement, from a feedback, but the feedback is not I tell you what to do, I give you some rewards for what you are doing, but you don't know if the reward that you get is the best reward that you can ever get, or if you need to try for something else. So the robot needs to learn by trial and error. And it is something very interesting, in fact, and it's really the subject of the PhD thesis of Marie, who is working with me, because when a robot is doing trial and error, it looks more similar to our human learning. We learn ourselves a lot by trial and error. And when we learn by trial and error, we need to try. We need to be curious. we also need to do mistakes. Mistake is not a big deal. You cannot learn without doing mistakes. So let me set up things for a reinforcement learning activity. So we will use the front sensor. Why not? I will use all the sensors. Let's go back to. So here I choose reinforcement learning. Now I don't want to see the graph. So in visualization, I will choose only the neural network. Now, in the sensors, I will choose all the infrared sensors. For the actions, I will choose go backward, turn, and maybe we will need sometimes, if we are too close to a wall, to go backward. And for the AI, we need more neurons. So in visualization, I will make the neurons smaller because it may be more visible. And then let's put, I don't know, 3 layers, each with 50 neurons. Okay, so we start to have a big neural network. By the way, we don't have to show all the details of this neural network. Put like this, that doesn't matter. And now let's choose the reward. You remember, reward, I said before, is only for reinforcement learning. So we choose obstacle avoidance reward. There are 2 parameters. One is a sensibility. I would like to test it because maybe 0.1 is not the best value. And the second, and second is penalty value. So I explain. When the robot will go straight, it will receive a reward of 100. You see, 100, 100, 100. But if it is getting too close to a wall, you see, so when a wall is detected at a distance, I mean, of 0.1, then the robot receives a punishment, -50. Okay? And the punishment, you can control it with the penalty. So the robot will need to find by itself when to go straight, turn left, turn right, or go backward. So I put it in the middle of the arena. And let's start. Maybe what I will do is I will turn off exploration just to show you something interesting. So the robot now goes, it turns backward, it turns to the left. It turns to the left, and it finds out that turning to the left, in fact, is good and gets a lot of reward. So it estimates that turning to the left has a value of 50. But now it never tries something else. So if I want it to try something else, I set up exploration. I put exploration, and now now you see that from time to time, instead of turning to the left, the robot will try something else. So most of the time it turns to the left, but you see, from time to time, it's going forward. And because it's going forward, it realized it goes too fast. It goes too fast. So far, the robot wants always to go turn to the left, but it discovered that when it went forward, let me make the robot go forward once, it received a reward of 100. So because of this, it is learning that, in fact, 100 is better than going forward is better than turning to the left. So now the value of going forward is slowly increasing. And if we go in the graph, you can see that the error is decreasing, because we are slowly learning that turning to the left is better. In fact, it is interesting because we can even learn while the robot is not moving. We say to the children, you see, it's the night, the robot is not doing anything, but it is sleeping. But during the night, its brain is continuing to think and to learn. And you see, during the night, the brain changed the connection to make more connection to the go straight action. And now, if we will wake up the robot has learned during the night and it will go straight. So let me do it. I wake up the robot because I can see here that now the go straight function is more valued than the turn to the left. Self-drive, yes, it's going straight. So you see with the ThymioAI solution, you can even show to children that it is good to sleep because our brain, or the brain of a robot, continues to learn during the night. Now let's continue, because the robot now also wants to go forward when there is a wall, but it receives a reward of -50. So now it will also learn that it is not good to go forward when there is a wall. So now the value of going forward when there is a wall will change, and the value of going backward will increase. We will wait until the robot will do an exploration for going backward. So you see now the robot has started to learn to turn before hitting the wall. Sorry, the robot has started to turn before hitting the wall, but it's not enough. It's still hitting the wall a lot and receiving a lot of punishment. But it is learning something. It's also learning to go backward. You see how the behavior of the robot is increasing. It did not find yet the best thing to do, but it is improving and improving. So let's look at the graph. So if we look at the loss, it's a bit puzzling because the loss sometimes increases, sometimes decreases. It increases when there are new unexpected experiences, and it decreases when we learn from this experience. So what we can look also is the reward. How much reward did the robot receive? So in the beginning, it was receiving a lot of reward because it was never hitting a wall. But then it started hitting walls and received less reward. So we can, here we have averaging. We can also look at this reward curve. So that we can see that from the beginning, the reward did not increase, but rather decrease. But now, with learning going on and going on, the curve of the reward will increase and increase. Look how it receives more often reward, because now it's learned to turn well in advance before seeing the wall. You see? So now we have the average reward, which is going up. And the average reward, you can see it also here in the level window. So the curve which I am displaying here, if I do not average, it is the reward at each instance. But if I average, it is the level across time. So we started with a pretty good reward level, but we were never going straight. And when we started going straight, the reward first decreased, but now the level, sorry, the first decreased and now is increasing and is reaching new heights. Okay, so now robots does its best. It's turning before the wall. It's just that from time to time it is still making exploration where it interrupts its motion. So if we want to use the robot without trying something else, we can cut the exploration, and now we have the perfect behavior. See? So just a parenthesis. Here I presented reinforcement learning quite lengthily. If you want to show to some clients, for example, more fast, you can just go to the videos, because you remember in the first video of Marie, in the second part, she was presenting reinforcement learning. So here you have a short movie where the learning appears in accelerate. So here you can see the movie of an accelerated learning, which is practical if you want to show to some people. So here the robot starts by always turning, then it will discover that going straight is better, and it will also discover that when hitting a wall, it is best to turn back.
Ainsi, progressivement, on peut voir que le robot apprend à évoluer dans l'arrêt. Après avoir appris à tourner, il a appris ici à se retourner lorsqu'il est tombé, ensuite à tourner pour éviter les murs, et enfin à aller tout droit en l'absence d'obstacles.
See, now it's going more and more often straight, and it reaches the perfect behavior. This was just a parenthesis. So here I presented reinforcement learning in the case of obstacle avoidance. Let me save the parameters because we did a great job today. Reinforcement obstacle avoidance. There exists a simpler configuration. It is possible, in fact, to remove the intermediary neurons, make the input much simpler, and still have some learning where we will again see all the details of the equations exactly as we did for the supervised learning mode. But this case, I will not show it today, but it will be present in our future scenarios. There is something else that we made is a balance reward, where, but this one also is a bit difficult. We will not do it. We put, let's say, Thymio on an object. I would need to prepare it. Let's say something like this. And Thymio will go up and down, and we will use its gyroscope and accelerometer to find out when the plate has an angle or not. And Thymio will need to read from his accelerometer to find out whether it needs to go forward or backward to equilibrate the balance. So these are a few examples of activities with reinforcement learning. Again, it will be possible for professors and students to introduce new activities, and we are also introducing a new button, program your own reward in Python, that will be available in future versions. So we are done with the advanced features. We can do a pause for questions, and then I will say a very few words about new features under development. But first, tell me if you have questions.
Only I have one, which is about the neural hidden layers because like I asked this question previously, I'm not exactly sure how do they affect the learning, because they do have an effect, obviously, but how do they work exactly?
So the best activity for this, is the 1D graph activity. In this, there are many things that you cannot do if you do not have an intermediary neural layer. So I started to go faster on this activity because I don't want to speak for 4 hours, but I will redo this part, okay?
Just briefly, because like to be honest, it's just like I just like a brief explanation of this. I don't think because this is like my question. I don't want to spend as many hours, especially that Camila and Piotr is here with me. So I don't want to like waste. I'm making them hear all of this complicated.
Maybe Thomas, maybe if it's possible, imagine we have to pitch teachers and professors, you know, and schools, right? How should we present those, you know, like intermediate layers in 1 or 2 sentences?
So the intermediary neural layer, the technical response is that it introduces non-linearities in the neural network. If you do not have it, the output is a linear function of the input. So, for example, you remember we wanted the robot here to make a specific action if the baby was too close or too far. But this is impossible. This is impossible with without intermediary neurons, because all the equations would be only the equations of lines, of straight lines, and straight lines cannot cross more than once. So if you want to, yeah, this is my fast response. We don't need to do it again, but the only way to detect it is so the only way to do complex classification. So here it's a classification between different measurements from these sensors. But when you do image classification, I mean, you recognize a cat or a dog from an image. It is impossible to do a complex classification if you do not have intermediary neurons. They bring more flexibility to the model. Otherwise, they will only do linear summations of the pixel values, which in some cases can work, but in most cases will not work.
All right, I get it. I think I'll get it. It's just like the best way to do more complex tasks instead of. I mean, it basically allows instead of like the best way. It allows to do more complex tasks instead of.
Yes, true. Yeah. It's allowed to do more complex tasks, and we can get much more precise in the activities.
Questions? Well, that was basically all the only question I had. And Camila and Piotr don't have any. Cool.
So now I want to talk about the future, the activities under development. So we want to. Thymio does not have a camera, but many of the computers that will be used will have a webcam. So we could use a webcam as an additional sensor for Thymio. So we do not have it. I cannot show you a demo now, but I will try. Please pardon me if it does not work, because this is a feature under development, to launch our code to take control of the camera. Okay, so I will just explain with Word. I will not do a demo. So the idea of the webcam camera is, in fact, you see me through the webcam, okay? So the idea is that we will control Thymio from the webcam. For example, in the software interface, there will be an additional sensor, which will be the webcam. And if you choose it, you will also see the camera image, and then the Thymio will be capable of learning from the camera image. So, for example, I can say, when I do this, turn to the right. When I do that, turn to the left. If I do this, go straight. You see, and I will be able to control Thymio from my webcam. Another possibility is to put the webcam on Thymio, and Thymio, so now I put Thymio, and it will learn from what it is doing. So, of course, then you need a webcam with a long cable, but that would be possible to equip Thymio with a webcam, or if you have a wireless webcam, I think this exists. So this was the first point. The second is advanced visualization of the data sets, because so far we went into this graph. You see, there was the 2D graph, there was the 1D graph. So when data has only one or two sensors, we are capable of seeing the data. So the first thing that we want to do is to be capable of editing this data. For example, add ourselves a new data point, remove a data point, reassign a data point. Say, okay, here we did a mistake. Instead of going straight, you should turn to the left. And we would like to extend this graph to any data, including multidimensional data or images. So in this case, it will not organize as a 2D or 1D graph, but it will just be to see all the data that we have in memory and the associated decision, and be capable of monitoring it, deleting some entries, reaffecting some entries, etc. And then other usages of the AlphaAI software. So you are aware that the AlphaAI software, we developed it first for the AlphaAI robot, and we are also selling it to use with other robots. And as distributor, you might be also interested by our other products, such as the AlphaAI robot. And in addition, we are thinking in the future to use it not with robots, but more with databases. So, for example, to understand what happens inside the neural networks for image databases, and also especially for text databases. And because today there is all these novelties around conversational agents and ChatGPT, we will introduce text training in the AlphaAI software. So now this will not have to do with the Thymio robots, but it's other features that you might be interested.
How advanced of a text-based generator are we talking about? Because there's a lot of models out there besides text ChatGPT. So are we talking like more like a basic one, like the earlier versions like DaVinci of ChatGPT, or like something advanced like Llama 2 or Pygmalion?
I really have difficulty understanding you. Maybe you can speak slower.
I'm sorry. I'm asking how advanced of an text generator model we're talking about here. Are we talking about like a earlier version of ChatGPT, like DaVinci, or something more advanced like Llama 2 or Pygmalion?
No, I am talking about something extremely simple. So yes, so this was, I realized that I was not sharing my screen when talking about the three features. So webcam, advanced visualization, and other usages. I will look for some ideas. I will share some ideas with you. Again, of course, it's in French. We were thinking to train a small neural network. For example, we give a few words, such as a man, a woman, some weight, bread, and we associate it with notions such as a farmer, a bakery, etc., a baby, and we train and we see how a neural network can learn associations between words and be capable of knowing about synonyms or notions that should come next. Then we could also, in our interface, make a small text prediction model that is capable of completing words and sentences. Like we start writing text, and it will complete the text as we have on our smartphone, for example, when we write text. It would be not possible to do very advanced models such as ChatGPT, because this requires huge resources, and all our models, they run on the PC. They do not require an internet connection, by the way. We have nothing on the web, on the cloud, only on the PC. So these are our ideas, but these ideas will help kids and adults understand that behind these text models, there are neural networks which learn to make associations between words, concepts, syntax, etc. I think we are done. So
I think so as well.
I thank you for your attention. I think it's a great thing that we did this recording. I hope that it will be of quality, so that it will be a resources that people can visualize in the future.
Thank you a lot, Thomas. You were very helpful today. This was a great presentation, very in detail. And we are very thankful for this because we definitely needed that.